Guess what just got found deep inside a black hole? It's causing quite the stir among scientists and everyone else. Joe Rogan's latest podcast is all about this jaw-dropping discovery. He's chatting about how it might be connected to time travel, dark matter, and even other dimensions. Could black holes be like secret doors to other parts of the universe? This revelation is seriously spooky and could totally change our understanding of everything out there. Come along as we delve into the dark and mysterious implications of this game-changing find. Section 1. What is a black hole? Have you ever wondered what lurks within the deepest, darkest corners of our universe? What if I told you that we've just detected something truly terrifying inside a black hole? These enigmatic entities have long been a subject of fascination and fear, captivating minds on platforms like Joe Rogan's podcast, where experts delve into the mysteries of the cosmos. But what exactly is a black hole? And why do they hold such a grip on our imagination? Black holes are one of the most mysterious and fascinating objects in the universe. At their core, they are regions in space where gravity is so strong that nothing, not even light, can escape their pull. Imagine a cosmic vacuum cleaner with an insatiable appetite for anything that crosses its path. This is essentially what a black hole is. The boundary beyond which nothing can return is known as the event horizon, a term that has become almost synonymous with the unknown and the unreachable. Black holes are formed when massive stars reach the end of their life cycle and collapse under their own gravity. This collapse compresses the star's mass into an incredibly small and dense point, creating a singularity, a point where density becomes infinite and our current understanding of physics breaks down. But to truly grasp what makes black holes so fascinating and terrifying, we need to dive deeper into their fundamental characteristics and types. Stellar black holes are the most common type and form from the remnants of massive stars. These black holes typically have a mass ranging from about 5 to several tens of times that of our Sun. Despite their relatively small size, they possess immense gravitational pull, enough to swallow stars and even smaller black holes. But even more intriguing are intermediate mass black holes. These elusive objects have masses between stellar and supermassive black holes, typically ranging from hundreds to thousands of solar masses. How they form is still a subject of intense study, but they might originate from the merging of several smaller black holes or from the collapse of massive gas clouds. However, the true giants of the black hole family are the supermassive black holes. Found at the centers of galaxies, including our own Milky Way, these behemoths can have masses millions or even billions of times that of the Sun. The formation of supermassive black holes remains one of the greatest mysteries in astrophysics. Some theories suggest they grow by accreting vast amounts of matter over time, while others propose they form from the direct collapse of massive gas clouds in the early universe. Now, imagine a discovery so profound that it could shake the very foundations of our understanding of physics. Joe Rogan's podcast recently highlighted such a revelation, a new, deeper look inside a black hole that has left scientists both awestruck and terrified. Using advanced AI and the latest in observational technology, researchers have started to uncover the 3D structure of flares and magnetic fields swirling around these cosmic giants. This discovery hints at a level of complexity and dynamics we have never seen before. One of the most intriguing aspects of black holes is their potential connection to parallel universes. Some theories propose that black holes could act as gateways or bridges to other dimensions, where entirely different physical laws might apply. Imagine stepping through a black hole and finding yourself in a universe where time flows backward, or where gravity repels instead of attracts. The very thought of such possibilities is both fascinating and terrifying. And then there's the question of Earth's fate in the shadow of these celestial giants. While the closest known black hole is still safely distant, the hypothetical scenario of a black hole coming close to our solar system is a doomsday scenario worth contemplating. The gravitational forces would wreak havoc on our planet's orbit, potentially tearing it apart. But black holes don't just pose threats. They could also revolutionize our understanding of the universe. The study of black holes is pushing the boundaries of theoretical physics, leading to new insights into the nature of gravity, quantum mechanics, and even the fabric of space-time itself. Recent upgrades to instruments like the Event Horizon Telescope have allowed scientists to capture unprecedented images and data, shedding light on the mysterious processes occurring near black holes. These advances are not just academic. They have practical implications for our understanding of fundamental forces and could lead to technological breakthroughs we can't even imagine yet. Consider this. What if black holes could serve as natural time machines? The intense gravitational fields near a black hole can cause time to dilate, meaning that time passes more slowly near the black hole compared to further away. This phenomenon, known as time dilation, has been a staple of science fiction, but it's grounded in the real physics of general relativity. In theory, a person orbiting close to a black hole could experience time at a different rate than someone far away, effectively allowing for a form of time travel. Joe Rogan's guests often speculate about such mind-bending possibilities, blurring the lines between science and science fiction. Section 2. Event horizons, singularities, and shocking discoveries. What have scientists just detected inside a black hole that has left the world in shock? The answer lies in a groundbreaking discovery involving AI and advanced physics models. By creating a 3D representation of flares around black holes, researchers have unveiled details that were previously unimaginable. This discovery not only provides a more detailed view of the dynamic processes occurring around black holes, but also opens up new possibilities for understanding the universe itself. Could this be the key to unlocking the secrets of parallel universes and the fundamental nature of reality? Using AI to analyze data from observatories like the Atacama Large Millimeter Submillimeter Array, scientists have managed to construct a 3D model of flares, or hotspots, that orbit black holes. These flares are incredibly energetic events, where massive amounts of matter and energy are released. By employing advanced algorithms, researchers were able to simulate the complex light-bending effects and the dynamics of these hotspots. The result is a detailed video showing the movement and structure of these flares, providing new insights into the behavior of matter under extreme gravitational forces. The implications of this discovery are profound. By understanding the behavior of these flares, we can learn more about the accretion processes that feed black holes, the mechanisms behind the powerful jets they emit, and the interactions between black holes and their surrounding matter. Moreover, this new capability could help us detect and analyze the signals from even more distant and less active black holes, broadening our understanding of these enigmatic objects. By studying these flares, we not only gain insights into the external behaviors of black holes, but also inch closer to understanding the mysteries that lie at their very cores. At the heart of every black hole lies a singularity, a point where the density becomes infinite and the known laws of physics cease to apply. This singularity is not just a theoretical construct. It is a region where space and time are so warped that our current understanding of reality breaks down completely. The concept of a singularity has intrigued and baffled scientists for decades. It raises fundamental questions about the nature of space-time and the limitations of our physical theories. One of the most tantalizing theories about singularities is their potential connection to parallel universes. According to some speculative models, the singularity at the center of a black hole could be a gateway to another universe. Imagine if, instead of being a dead end where matter and information are lost forever, a black hole's singularity leads to a different realm of existence, a parallel universe with its own set of physical laws. This idea has been a topic of much discussion, including on Joe Rogan's podcast, where he explores the mind-bending implications of such a scenario. However, the singularity is also a place where our current understanding of physics reaches its limits. The equations of general relativity, which describe the gravitational forces in and around black holes, predict the existence of singularities. Yet, these same equations fail to describe what happens inside a singularity. This breakdown indicates that a new theory of quantum gravity, which merges general relativity with quantum mechanics, is needed to fully understand these extreme conditions. Equally important is the concept of the event horizon, the boundary surrounding a black hole beyond which nothing can escape. The significance of the event horizon extends beyond its role as a boundary. It represents a fundamental limit on our ability to observe and measure the universe. The existence of the event horizon challenges our understanding of information and its preservation. According to the principles of quantum mechanics, information about a physical system should never be lost. However, when matter falls into a black hole, it appears that this information is irretrievably lost behind the event horizon, leading to what is known as the black hole information paradox. This paradox has profound implications for our understanding of the universe. If information is indeed lost in black holes, it would imply that the fundamental laws of physics as we know them are incomplete. Resolving this paradox is one of the greatest challenges in theoretical physics, and it could lead to new insights into the nature of reality itself. Black holes, those enigmatic cosmic monsters, might be more than just destroyers. They could be portals to other dimensions or gateways to parallel universes. This idea, while speculative, has captured the imagination of both scientists and enthusiasts alike. According to some theoretical models, the singularity at the center of a black hole could connect to another point in space-time, potentially leading to another universe. Could black holes be the keys to unlocking hidden realms beyond our own? This concept aligns with the theory of wormholes, hypothetical tunnels through space-time that could create shortcuts between distant parts of the universe or even different universes altogether. What if I told you that black holes, those seemingly eternal cosmic giants, could actually disappear over time? This shocking idea comes from the groundbreaking work of physicist Stephen Hawking, who introduced the concept of Hawking radiation. But what exactly is Hawking radiation, and what does it mean for the fate of black holes? Hawking radiation is a theoretical prediction that black holes can emit radiation due to quantum effects near the event horizon. This radiation arises from the creation of particle-antiparticle pairs at the edge of the event horizon. Normally, these pairs would annihilate each other almost immediately. However, if one of the particles falls into the black hole while the other escapes, it effectively reduces the black hole's mass over time. This process is incredibly slow for large black holes, but could lead to the eventual evaporation of smaller ones. The existence of such powerful and far-reaching jets raises unsettling questions. Could these jets ever pose a threat to our galaxy? While our own Milky Way does contain a supermassive black hole at its center, there is no immediate danger from its jets. However, the potential for black hole jets to disrupt entire galaxies and alter the course of cosmic evolution is a sobering reminder of the immense power these objects wield.